topic is multicast. It's the BIER. It's the new multicast architecture in segment routing arena. So in 2024 EANTC Interop event, we have 4 participants. Juniper, we have PTS 10002 36 QDD, and from Nokia we have a 7750 SR1, and from Huawei NetEngine 8000, and from Keysight IX network. So before I get into the actual demo, let me give you a brief introduction about BIER. Okay, the concept behind BIER, it's very simple one. So in order to understand the BIER, right, just imagine that you have a service provider network with 100 nodes, okay, 100 provider edge node, and we have a multicast source address behind P1, and we have 10 P nodes as receivers, okay. Now, the precondition here is we don't want to build a multicast point-to-point MDT tree within the core of the service provider network, right? And we don't want to have a P2B tunnels. We don't want to have ingress replication. We don't want to have a PIM infrastructure. But how to send the multicast data without building an MDT tree, right? So one option available for us is, we know that, okay, we have only 10 receivers, and we knew that the IP address of those 10 receivers, right? So what we can do, we will create a multicast header packet with destination address wherein all the 10 destinations are listed there, right? So the problem here is, if you look at IPv4 address, we have 32-bit address schema with 4 byte of information. So in order to address 10 hosts, right, we need 40 byte of header information. Now, in the service provider, let's say that we have receivers for entire 100 nodes, right? So we will end up in creating a multicast header packet with 400 bytes, right? So if you translate to IPv6 with a 128-bit addressing schema, we have 16 byte of header information. With 10 nodes, it will consume 160 byte. With 100 nodes, right, we will end up consuming 1,600 bytes of header information, right? So that is not a viable solution for us. So the concept behind BIER is very simple one. Instead of the 32-bit IPv4 address or a 128-bit IPv6 address, what we can do, we will configure a unique ID. It is nothing but the BFR ID for each of the P nodes in the provider edge network, right? Service provider network, right? For example, P1 will be configured with a bit ID of 1 that represents a bit position in a bit string, right? Which will be encapsulated to our multicast data. P2 with BFR ID of 2, and similarly with the P100 with bit ID of BFR ID of 100, which will represent the MSB bit in the bit stream, right? And as and when the multicast packet comes to the provider edge router, it will be encapsulated with its BIER header, right? And it will be sent to the core, right? So once the packet receives the core, what we have to do, we need some infrastructure to look into the tables and to figure it out what kind of replication we have to do. Then we have to send to the next neighbor, right? So in the BIER architecture, we have 3 layers. One is the underlay, and another one is the BIER layer, and third one is the overlay. With underlay, we have IGP, OSPF, or ISIS, or it can be BGP, using which, right, we can build the BIER routing table or BIER forwarding table. BIER layer is nothing but the encapsulation which we are having on the multicast data. And we have overlay. Overlay is something like, okay, we have 100 provider edge nodes in the system, and out of the 100 provider edge nodes, we have only multicast listeners behind only 10 nodes, right? So we have a provision to figure it out who are all my interested multicast listeners. So overlay is the mechanism to provide that. Currently we are having EVPN or multicast VPN or IP multicast acting as the overlay. So the node at which we are having this the encapsulation happens, right? That is the ingress node. It is called BIER forwarding ingress router. And the node at which we are having the decapsulation is the egress node. It is called BIER forwarding egress router. So this is the topology which we used in Berlin for the Interop, right? There were 4 players, actually 3 players, including XA we have 4 players. So for today's presentation, we are having only 3 players. Juniper, PTS 10002 36 QDD, and from Nokia 7750 SR1, and from Keysight. So the functionality which we are currently showing is the underlay part. So what we did it, we enabled ISA's protocol within this network, right? And for BIER functionality perspective, the Keysight, the IX network will be acting as the BIER ingress node as well as the egress node, right? And so the Juniper router and Nokia routers behaves as the transit node. So as and when the IXIA sends the multicast data with the BIER header, it receives at the Nokia or the Juniper node. It will look into the multicast BIER header and figure it out, okay, these are all my destination nodes, right? And it will do the replication. So let me get into the actual demo. So we have PTX 10,000 36 QDD here. So we have, from Juniper side, we have adjacency. So we have ISI's adjacency towards the IXIA, which is our BFIR node, and two of the Nokia nodes here. So if you look at the database of ISIS, you can use this one. Here we can see here we have odd nodes here, 21, 11, 41. Those are all the BFR IDs which I configured in the IXIA. So we have a routing table created from both RE perspective as well as from the forwarding perspective. So show route table, we have the BIER forwarding table which carries all the BIER forwarding informations, right? And we have show BIER neighbor info which contains the forwarding bit mask information and the different neighbors it is connected to. So what I'm going to do, let me trigger the traffic from IXIA. Is it on? So before static is on. So if you can see here, I have the input packet here and output packet counter here. So this ET0020 is connected to my IXIA port, right? It is receiving 1000 packet, and that 1000 packet, right, it is replicated to 1000 each to each of the Nokia nodes. So 1000 packets are coming and it is got replicated to 1000 packets to each of the Nokia nodes. So the transit node, the Juniper PTX 10,002 acting as a transit node, receives the multicast data with BIER header, then it do the replication and send to both of the Nokia nodes. Now let me invite Hooman from Nokia. He will be now showing the Nokia related information.
So, hi, my name is Hooman Bidgoli. I'm from Nokia. I'm an active member in the IETF for BIER. As you folks know, when it comes to BIER, it's very hardware oriented. Our FP4, FP5s, they do BIER. And also when it comes to the Broadcoms, the J2 and J2C Plus going up there, they also do BIER. Now, one thing I just want to clarify when it comes to BIER, it's really source routing for multicast. We really compressed the seed to a single bed. So that's the way you should think about it. All the leaves on the network that are interested to be part of the multicast, they are presented by the appropriate bed on the source router, on the root router. So really think of microseed as a single bed throughout the network. We build our forwarding table based on those identifier, the bits that are each one of those routers are advertising through the network. And I'm not going to go through the statistics and bits and bytes. I'm just going to show you guys that I'm sitting on one of the root routers, which is also the leaf. And I'm going to show you the So here's a routing table. It's not the forwarding table. I'll show you the forwarding table later on. As you can see, there is this idea of 21, 10, 11, 40, and 41. So those are the BIER identifier through the network. We build this information, and eventually what we do is that we use it in the forwarding table. And I never realized how hard it is to type with one hand, but hey, oh, you can use this one? It's working? All right, sounds good. And here you can actually see the seed, the very compressed seed, or the bits that are actually sitting within the BIER header. So to present the BIER ID 21, does the mouse work? Yep. So to represent the BIER ID 21 here, the according bit is set in the BIER header. And that's the case for all the other leaf routers throughout the network. That's how we build our routing table on the router. So when the packet comes from IXIA, it's going to hit the BIER forwarding table. We're going to go through the bits of the packets. We're going to match it to the forwarding table as per these bits that you can see here. And based on those bits, we're going to figure out what is the OIF, and we send the packet to the next router down the road. Source routing for multicast. Now I'm going to hand it off to our XIA colleague. My apologies. I put extra I in there for you.
Thank you, Hooman. Hello, everyone. Malake from Keysight. And to support the BIER testing, we are using our layer 2-3 network emulator and traffic generator IX network. Here we are directly connected to both nodes, Junipers and Nokias, throughout chassis. We have enabled ISIS on both sides, and under ISIS we can configure the BIER settings. Under ISIS router, as you can see, for example, here, we have like one BIER subdomain. Afterwards, we can do all the settings that we want, like for the subdomain ID, the BFR ID for each node, Nokias and Junipers, and specify the labels for each of them. So once we start the protocol, everything is going, the protocols are working perfectly. We can generate traffic. So as Suneesh showed you earlier that we have already generated traffic and it's working perfectly with no loss. Let me show you one specificity that we have. For this test, we are generating a raw traffic between the nodes, and our packets is constructed automatically based on what IX network fetched as LERD info, or based on what we did as settings. But we have a cool feature where we can change the settings manually on the encapsulations and put the labels, for example, for the bit strings label for each vendor, for Nokias and Junipers. Here we can specify the bit string for the egress port and the MPLS label in here for Junipers and Nokias. So we can have a preview of our packet, and we can see that this is the source destination, this is the source and the destination MAC address and the label value that we have set it manually. And then we can start the traffic. It will take just 6 seconds for the GUI to refresh. And you can see here that the loss, there is no loss, 0%, sorry, and everything is working perfectly. So this concludes our test. Thank you so much for attending. And if you have any more questions or insights, feel free to reach to my colleagues. Thank you so much.